We are naturally inclined to learn about the past. For Earth's history, we look to the rock and fossil record to learn about its past. But how do we put a voice to rocks and fossils? Well, we use science to piece together and extract their stories and connect them like a jigsaw puzzle that is the Earth's history. Now we apply the same concepts to Mars, and let's look at this slide behind me. This is our current understanding of Mars and its relationship with water. Not very much, isn't there? With the rock on the bottom-hand corner here, in addition to about 200 Martian meteorites, satellite data, and rover data, it still isn't enough to paint this picture in much more clarity. So this is where we need hand samples, and we need to find them here on Earth. This is where my team comes into play. We look for rocks and minerals that share the same signature as those we find on Mars. And for my case, I generate, or I synthesize in lab, smectites, clays, Martian clays, essentially. And then I send them through dissolution experiments. We put these clays, these minerals, into water, and we see how fast they break down. When we get a dissolution rate, we back calculate, like we do with math when we start with the answer. And then we get the rate of formation. How fast did rock and water interact on Mars to get these clays? Then we take all of this data and we input them into a modeling program, which gives us the best case scenario as to what happened in the past, the environment of Mars, to generate the rocks and minerals that we see today on the Martian surface. Essentially, it's a really tiny piece of the puzzle to this slide, but it's an important piece nonetheless because it eventually helps us answer the question, where did the water go on Mars? Thank you.